Okay, hello everyone. For the people that are still coming, please, there's plenty of seats. Hello and welcome to the Decomposing Java Applications talk. Appreciate you came to this talk considering there is Spring Boot going on in the other room and this one is the only one in English. It's a really impressive crowd. My name is Milen Dyankov. I work for a company called Liferay, and just out of curiosity, how many of you know Liferay? All right, a few people. Okay, so my role at Liferay is developer advocate, which basically means I get to go to events like this, or go to customers and partners, talk to developers, try to figure out how the things that we do help them be more productive and do better their job as developers, and bring the feedback to the company. So for those of you who don't know what we do quite a lot of things. Maybe you're familiar with the portal in the past. That was like one product that we had. These days we have a lot of other things. We have a bunch of front-end libraries. We have a bunch of like cloud services and stuff like that. But still the biggest one is the Liferay Platform, which I call it like this. And this is the evolution of the portal. And so people typically ask me like, okay, so what is the platform? And I, as a developer advocate, I struggle to actually explain this to them in a good way. So I say, well, you know, it's a platform where people kind of deploy services, and it comes with a lot of pre-ready services. And so people will go like, oh, so you're doing microservices? No, we don't. Oh, so SOA? No. So failing to put what we actually deliver in like one buzzword, it's the thing that I've been struggling with for quite some time. And this is kind of the root cause for this talk, which has an alter title, which is Cleaning and Tidying Children's Rooms. How many of you are parents? How many of you have children? Okay, not so many. So this is something that many of you will experience in the future, is when you have old enough children and you tell them, you know, go and clean your room. And they will say, wait a minute, well, what do you mean? My room's already clean, right? Or you're gonna go and say, like, clean your room, and you're just gonna grab two things, put them here and say, it's done, right? And I figured this is the exact same thing that I experience with developers when you tell them about a concept that they wanna just grab a bunch of lines of code, put it in there and say, done. My code's clean, my application's great, right? And they fail to kind of dig deeper into the concept of what exactly does it mean in clean code? What exactly does it mean in good architecture? And it's not about which framework you choose to use, but like what is it? Why, in the first place, I have to think in the terms of a clean architecture and design and application decompositions. Those are like so abstract things for developers, much like cleaning the room is an abstract term for kids. So how do you approach that to explain this to kids? Is by example. How do you approach to explain this by developers? It's hard. How many of you have heard of a Conway's law? Okay, it keeps surprising me that in the era of microservices, not a lot of people are familiar with the Conway's law, which basically says an organization that designs a system inevitably going to design a system that's going to represent the organizational communication structure. In other words, in whichever way you communicate or your organization is organized, that's how you build your applications, right? And that's a very popular law in computer science. So I thought I'm going to give you an example by reversing the Conway's law. So if that's true, that means that we can grab any application structure and convert it to an organizational structure. Right? So this is what this talk is going to be about. We're going to be pretending that we are building a business. And we'll see different ways of doing that, and you'll figure out, I'll let you, by yourself, figure out what works, what doesn't. I'm not going to make any decisions for you here. By the way, I'm going to rush through the code. This is typically like 1 hour talk, and I need to fit it in 45 minutes, so I'm going to really rush through the code, but don't worry about it. Code is online if you want to play with it later on. It's not the purpose of this talk for you to understand every single line of code. It's the decomposition and the design and how we structure things rather than what exactly this line of code does. Okay, so let's get started. Let me introduce you to Harry. Hari decides to run a home business, like a one-person business. He's going to be doing house cleaning, right? So he gets his van and his cleaning tools and his cleaning supplies, and he builds a company that people call them, and he grabs the stuff, goes to their houses, clean the house, get the money, go back. Simple, right? What this look like is pretty much this. So here's our Hari. Sorry. And Hari is a person, single person, and he has his cleaning tools, and he has his van, and he has a bunch of other things, and he can clean houses, right? So he first, when you call them and say, clean my house, he's gonna check if you pay him enough, and then he's gonna go grab the cleaning tools, grab the supplies, put them in the van, drive to the house, clean the house, put the stuff back in the van, drive back to the company, put the cleaning supplies and tools back, and register his income in some kind of a bookkeeping system. That's pretty much it. That's how the logic goes, right? Also, Hari is a person, and so now that he has a van, he can actually borrow his van to someone, right? So if a friend calls Hari and says, borrow me your van, he will say, sure, here it is. But if it's not a friend, Hari will say, sorry, I don't know you. And the same thing goes for borrowing Hari's tools. Right? It's very straightforward and simple. And that's pretty much all it is. I also have this thing client, which you're going to be seeing through the rest of the demos. And it's just a stupid shell application, so I can call methods on a variety of objects. So don't pay attention to that one. So let's go to this house cleaning example 1. And just run this. I'll skip the compile phase. I have this everything pre-compiled just for the so we can get the stuff on time. I have this run script here, and when I run stuff, I need to say which Java version I run stuff with. This is going to be with Java 8, and you will see later on why the Java version is important. So let's run this here. Hey, we have this house cleaning shell here, and here I can say clean my house. And Hari is going to say, okay, pack the stuff, drive, go, clean, come back, done. Okay, but I can also say, hey, borrow me your van. And Hari says, sorry, but I don't know you. I don't know who you are. I say, what do you mean you don't know me? I'm a friend. And Hari says, oh, yeah, sure, I recognize you. Here's my van. Now Hari's out of business because I've taken his van, gone on vacation. Right? But that's a different story. So this example is like super simple, and this, if you think about it, is how we all started once upon a time building Java applications. And it has one significant advantage. It's everything in here. It's everything in Hari, right? If you want to change something, it's in here. If there's a bug, it's in here. Whatever happens, it's in here. You know where to go, you know where to change. There is nothing to share with anyone else, all in one place. Super cool, except it's not scalable. You can't do a real business this way, right? It's not going to be always only Hari, and it's going to grow to a large enterprise. And Hari comes to realize that. So he goes and gets his friend Ronald, and now Ronald's going to be dealing with the customers, right? So here we go. So he comes up with this order form. So he talks to customers. Customers fill up the order form, and then they called Ronald. And then Ronald in here is going to call Hari, get the stuff from the order form, tell him where to go, what to clean. From Hari perspective, that's pretty much the same thing. You know, he just owns the stuff, except he looked into the market and realized that all the house cleaning companies invest in this super cool thing, which is called a smart garage. So he also decided to invest in one of those. Now, what a smart garage is? A smart garage is one that you can say, give me all the cleaning tools from blah, 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 where criteria match, and then the garage gives it back to you, right? Not that Hari definitely needs that, but that's what everyone else does, right? So he gets one of those. Okay. So in the same scenario here, and let me put this on a bigger screen. So we're now going to go to house cleaning 2, and we're just going to run this again with Java 8. So here we go. We say clean house, and now you will see that actually Ronald is the one who picks up the order, then the smart garage tells Harry which tools he needs to pick up, and then he loads the stuff in the van, goes down, basically the same thing, right? Now what's going to happen in here if I say, can you borrow me your van? Here you go, I just borrowed the van. Now how in the world that happened? Well, that happened because we hit Ronald and not Harry, right? And if you see in Ronald has now a borrow van thing, and he can totally borrow the van without even Harry knowing about it. And that is possible because all Harry, Van, and Ronald are in the very same space, and Ronald can just grab and borrow stuff without even Harry knowing about it. Now, that's not necessarily a problem for as long as you only have Harry and Ronald in the company, but if you attempt to grow a company this way, with hundreds or potentially thousands of employees, you don't really want every employee to be able to borrow random stuff to random people and be totally out of control of what's going on where, right? So Harry's like, nah, this is not going to work this way. I have to think of another way to structure my company. So we go to example 3, and in here, okay, just before we go to example 3, because I'm skipping the slides now. So this is this example that we just saw, the house cleaning 2. So you have the Harry. Harry's kind of hidden now from the customers, but still, and in garage is kind of hidden from the customers, but still Ronald can just bypass Harry and grab the stuff, right? And this is like not a situation you want to be in if you want to grow the company. Okay, so go back to example 3 now. So now Harry is smart, and he divides the company into units, right? And so we have here the assets unit, and in the assets, we have the garage, where is the van, and we have the storage, where all the cleaning tools are, right? And we also have the company itself, where there is Harry, and he decided that he can't do the stuff by himself, so he needs an assistant. So he got Andre to help him, and Andre is now, as you can see, responsible for getting stuff from the storage and preparing the cleaning tools and the supplies for Harry, basically. And then we also have the front end in here, the front office in this particular case. And the front office, what we have is, again, Ronald and his order form. Okay, so let's do this example again. And then we go to house cleaning 3, this case, and just run it again with Java 8. Here we go. So clean the house. It works exactly as I expected. You will see that Ronald gets the order, Andre now prepares the stuff, Harry is cleaning, basically the same thing. So this is this, right? You have divided the company into 3 different things. Our assets are big, way back hidden. Harry is like supervising Andre, who is somehow of a hidden, and Ronald is the one taking care of the customers. All super cool, except I still can do borrow van, and boom, can still do that. And why is this happening? Well, this is happening because now, in order for those cleaning tools and garage and stuff to be available to Andre and Harry, they also need to be available. They also automatically available for Ronald. So if you look into the code, I can try to go here to the assets and say, for example, my garage is going to be not available, but that automatically makes it not available for Harry and Andre as well, which is not what I want. So there's basically no way to physically prevent this stuff from happening. So if you've done this, and I think you just don't know, what you actually have done is what I call the universal BBC software architecture, which is the universal box cylinder. Right, and now you're free to call those things whatever you want. Typically, people call them like front-end, business logic, and database, or you can come up with fancy names for those. But that is essentially how we were taught that we should build application for last decade, right? And obviously, it has some disadvantages, so we moved away from that. And also, Harry looks into that and says, "Nah, this doesn't work very well. I try to figure out another way to structure my company." All right, so we go to the next example. in which we divide or decompose, if you prefer, the application in a different way. So we now have, again, the front office, which is the Andre with his form. Nothing changes here. Now we move Andre to the back office, and so together with the, like say, here's Andre, and here's the storage. So now Andre is responsible for the storage, right? And then we have the company where there is Hari and the garage, right? And if you try to do that, here we go with the example 4, and just run this again with Java 9. Clean the house, totally fine, but borrow the van. Oops, now it doesn't work. Oh, we have some serious issues with the sound here. Now it doesn't work because, well, the garage is now in Hari's like maintenance kind of thing. So Hari will check, say, I don't know you. But what's going to happen if we borrow the tools? Well, the tools, we can still borrow them. Why? Let's have a look at the diagram in this case. So this is basically what we have. We have the front office, the company, and the back office. And Hari still can check whether you're a friend or not, but there is nothing that prevents Ronald from going straight to Andre and ask Andre to borrow the tools. And Andre doesn't have the knowledge of whether you're friend or not, or whether it's Hari's friend or my friend or whatever. So they can still do whatever they want. And this is still not a business model that you want to have if you plan to grow your company. And if you've been doing this, and I bet you've been, because that's what everyone does these days, it's the universal microservices architecture, right? Where you have a service, and you put the word micro because it's fancy in front of it, and then you stack all the stuff in like Docker and databases and whatever you want to put in there, like the whole JVM, and then you call this a microservice, and then you have one REST point there everyone is hitting you, right? And it's super cool, but again, it has some complexities tied to it. And as the thing grows, you happen to realize that all of a sudden now every microservice needs to talk to every other microservice in order to get anything meaningful done. Well, okay, let's see what else we could do with that. So here goes example 5. I'm going to actually skip the example 5 because it's identical to example 6, with the only difference that I'm going to explain in a second. But so the declaration here is, again, we have the company, and the company is now divided internally into different stuff. I need that one. I can't have it in my hand. No? Well, oh, okay. Well, I can't type and fold this. All right. Let's see if we can figure this out somehow. Nah. Here we go. All right. Better? No? Nah. Okay. So here we are. I'll type with one hand, but that's terrible. So let's exit here and go to example 6. And again, compile this with, this is now running with Java 8. Okay, let me move here. Okay, I didn't even, sorry, I got off track now. I didn't explain the code to you. I started with the demo right away. So let's back to the code. So now the company is divided into internally into some stuff. Like we have like things like job positions. Like what Hari has happened to realize at this point is that it's no longer about Hari and Ronald and Ray and people like personas, but it's about company, about business models and how the stuff actually works in businesses. So we now have things like job positions in here. So we have, for example, a cleaner which can clean a house. We have a receptionist which receives payments and prepare cleaning instructions and stuff like that, and an assistant who does a bunch of other things. So those, as you can see, are definitions of roles, right? It's not the actual stuff in it. And so we also have processes in here. And these processes or how our company actually functions. So let's say, for example, the clean house process. It's super simple. Get the cleaner, tell him to clean the house. Like transport process is, get the van, put the stuff in it, drive, and whatever. We also have some stuff that we share in between different kind of departments. So this is like when we say something went wrong, or this is where we say, for example, this is the result of this process or whatever. So we still need to share things about things. And then in here, in this internal stuff, we actually have the things that are responsible for all this to work. So if you look into the assets, this is like where is our software, our storage, our vehicles, whatever our assets in the company are. And in the staff here, we have Andrei, who is an assistant. We have Hari, who is both cleaner and accountant. And we have Ronald, who is a receptionist. So we basically said, okay, from company perspective, it doesn't really matter which person it is. What it matters is the role that they play in the company. And why is this called internal? You will see in a second. Well, the obvious intent, it is obvious the intention, right? It's no one outside the company should care about those things. These are internal things for the company, right? But can we actually do that? That's what you will see. Right, so this is what we have from a company level. And now you have to also define, and Hari has to define in this particular case, okay, so we structure the company in a particular way, but how do we actually use that company? Like how people out there use that company. And this is where this other thing called use cases come into play. And in here, you have, like, for example, a cleaning request use case. Customer, what is it called? Customer use cases, where you have a clean customer house use case. So this is the basic use case where people say, I want you to clean my house. And so what happens in this particular case? Well, we go to the new order process the order, make sure the payment is okay. Yes, thank you. Oh, okay. All right. Okay. So we now have the new order process. Once we're done with the new order process, then we check the payment. If not, we fix the payment. Then we prepare the instructions for the cleaner, get the stuff. This is our prepare for cleaning process. Then we have a transfer process that drives us to the company, clean the house, transfer process to get us back. So we, instead of like telling this person does this, we've actually defined a process, like what happens in the company when this use case has place. Okay, so how this works now. So this is again running here with Java 9, and if I go to run this again, which I did, I'm running it already. I can say clean house. Yeah, I changed the logic here. We need to provide a price. So can you clean the house for 100 euro? Let's try again for 10 euro. And you will see that the process actually goes to the front office, to the receptionist who says, no, that's not enough. You need to pay us more. Okay, good, fair enough, 100 euros. And now the process works. And you will see that we still have like Ronald and Andrei and Hari doing their own thing. Right, but can I still abuse this to borrow the van? Oops, I can. Can I borrow the tools? Oops, I can. Why I still can do this? Let's look at the, this is the example 5, which I skipped, but again, code is the exact same thing, and you will see how this differs with example 6 in a second. So this is how we divided stuff now. We have the company, which is internally divided into different things, right? And we have the use cases. And now by having those use cases, what we actually can do is we can acknowledge the fact that there may be more use cases in the future. In the future, if our company decides to, I don't know, clean backyards or swimming pools or something else, we can actually introduce use cases for those by using the exact same infrastructure that the company itself provides, right? So it makes it easier for us to introduce new use cases in the future. And then we have the front office stuff, which kind of access these use cases, and which also gives us a flexibility to, oh my gosh, which gives us a flexibility to basically provide a new communication channels. So if we tomorrow say that we're going to serve customers in a different way rather than asking them to fill in a clean house form, yeah, that's just a matter of another front office way of doing things, right? The problem still exists, though, is that from the front office, we can skip the whole use cases and go straight to the private stuff of the company. We can get a particular person and tell this person, give me the van, and they will give the van for you. There's no physical way to prevent that unless you do this. You can say Maven clean package, and now we want to build stuff, but with Java 9. And now, what happened here? There you go. And now, what's going to happen is there's going to be a nasty error in the front office. What happened in the front office? Why we all of a sudden cannot compile this thing with Java 9? Well, we can't, because what we did in here is we put this crazy module info file in our, let's try the company, module info file, which basically says, well, guess what? This is now a real module, and the only thing that it provides to the outside world is those three things. That's job positions, processes, and shared stuff. And anything else inside that module is none of your business. You're not allowed to touch that, right? And if you go to the use cases, it says, well, we require the company, right? So whatever the company exports, and basically we export use cases for other people, which in this case is the front office, to use. So this now actually allows you to prevent the stuff from happening. So actually, there's no way to cheat in here. The only way to do this properly is to go to your front office and say, well, yeah, now I can't do this anymore. So sorry, you can't just request on the front office that we borrow the van for you. And once you do this, you can actually compile your stuff with Java 9 now, because now you're following company procedures. You're not doing crazy things like, okay, well, yeah, okay. Another thing about Java 9 is that it also, it's not so super smart. JPMS, actually, it's not about Java 9, the Java Platform Modular System. It's not super smart. If you import stuff, it assumes you use it, so you actually have to comment out the imports as well. But this is now supposed to be supposed to compile properly with Java 9. Here we go. And obviously, if I try to run this now with Java 8, it's not going to work because, yeah, no modules. So I need to run this with Java 9 on module path, and here we go. And I can say clear the house, and it works. And if I say borrow the van, it says, well, sorry, this company does not offer this service to you. So from like diagram perspective, this is what we did. We actually did what we intended to do, where we were not able to do before, which is hide part of the stuff that is not to be exposed to anyone, right? So all these internal packages are now hidden. Now you can't, do crazy things with them and, hire a person or a developer, person that, 3 months from now is just going to look at the code and say, oh, that looks nice. I'm just going to use that. And 6 months from now, you will be like, why in the world this works this way? Anyways, so this is one way to design applications. So we finally got rid of this this use case that someone's going to borrow our van without us even noticing. Now let's look at one other aspect of this, though. I'm just going to go to the transport process. which is into internal. Where it is? Come on, come on, come on, come on. Processes. Here we go. Transport process. And in this transport process, I've added a method just so that I can demonstrate this to you, which checks whether the van is functional. So we never thought of what's going to happen if our van breaks, right? We are a business, right? And it checks a properties file in here to actually make sure van is okay. So this is this thing called status in here. So let's go back to my terminal. And hey, can I clean the house? Sure I can, but guess what? My van just broke, right? Can I clean the house now? No, because I have no way to go to the house anymore, right? And what I'm supposed to do now? I'm supposed to shut down the company, fix the problem, and restart the company? No, this is not how it works in a real-world scenario, right? So Harry thinks about doing this better way. So here goes another example, which is basically the same code. The only difference in here, though, is that we now have processes also defined. Instead of processes that we are exposing to the outside world, we are exposing process definitions. So basically we say, if something is a transport process, it has to be able to drive me from one place to another, and so forth. And so how do we implement this? Well, we internally implement this by this thing called internal transport process, which is basically the same thing that we had before, right? And why we are doing this? Because this way, we could also go and sign up a contract with someone who also provides this, say Uber. We say, hey, Uber, in case our van is broken, can you give us a ride? And Uber says, sure, I can. And here is your Uber transport process, which is basically the same thing, but implemented in a different way. Now, let's look at the module info, how this changes in here. So now we not only export stuff in here, but we also say, well, we provide those services with a particular implementation of those services. And the same thing in here, Uber provides stuff much like we do. And from the use cases perspective, if you go to the customer use cases, we use this thing called service loader. And now, show of hands, how many of you are familiar with service loader in Java? 1, 2, 3, 3 people. Yeah, but that's not surprising at all. Service loader showed up in Java 6, by the way, which was quite a long time ago. And every single time I do this in previous talks, I'm surprised to know that people don't even know service loader exists. Anyway, so we just basically say here, find me an implementation of a service, and this is how the thing works. Now, because I don't have a lot of time, I need to just make sure that I have this module, the Uber module, enabled right away, so I can do the demo properly. And so here we go. We're going to go now to the example 7. Which is here, and we're going to run this with Java 9 modular system. And I'm going to say, clean the house, it's going to work, and then I'm going to say, well, my van just broke, right, and clean the house again, and you will see, well, now we are using a different thing. Now we are using Uber to actually go to the customer rather than using our van, which is broken. But then, hey, they fixed the van, right? So clean the house again, and here am I using my own van again. And this is what services gives you when you decompose your application in this particular way. So how this works is that you actually hide as much of your stuff that you can, and then you just expose this as contracts, as services. And then someone, instead of saying, I want this implementation of something, says, give me a implementation of that particular contract, right? And in this way, we can do dynamic stuff like we did, like switching one implementation with another. Now the problem with that, well, it's not really a problem, but it's like something that you immediately notice probably, is that you need Java 9 or newer in order to benefit from that, because this is where JPMS showed up. That's one thing. And the other thing is you need to have all the modules available upfront, because Java JPMS doesn't have any notion of dynamically loading modules. Right? So if those are important for you, well, here is how you can actually do the exact same thing with Java 8 and basically have it dynamically. It's called OSGI. So in this particular case, the code is pretty much the same, except in the company, we have, again, the same thing, processes and internal implementation of that processes. But in here, we are just using connotations to basically register this as a service in the service registry, right? And whenever we use this, which is the use case, we are gonna just say reference, and the service register is going to give you a implementation of something. Now, in this particular case, for the transfer process, we say we want this to be dynamic. That means we can get new implementation, new services whenever they are. And that's pretty much the same thing. We get all the processes and figure out which one we use, and so forth. We don't have module info here. We don't have anything Java 9 specific in this particular case. So I'm just going to go to the last example of today. And I'm just going to say run this with Java 8. And the shell is going to be a little bit different here because I'm using GoGo shell from the OSGI Felix project, but it's underneath the same thing that I was using before. So if I say here clean house, and I say for €100, here is my process going on, running exactly the same way on OSGI runtime. And if I say status, my van is broken, and I try to run my process again, it says, oops, sorry, but I don't have any way to go to your house, right? I don't have the transport process. The van is broken. So what I'm supposed to do now? Well, I can do install, and then I just can go to my Uber transport in here, get whatever I have in there, and just say, install that thing. And if I look at my modules, well, it's installed but not active, so let's start it. And let's look again. Oh, now it's active. So can I now clean the house? Sure I am. And I just dynamically install a module, and I can go and get my job done. And the moment they fix our van, I'm back to using whatever I have in the company, right? So this gives me flexibility to react to changing environments, and it's essentially, like if you think 8 examples, they are all using the exact same business model. Like I have a company, I want to go clean houses, but when you think about it from the perspective of a Hardy running a business in his garage, like this makes totally nonsense, right? If you think about it from the perspective of Hardy trying to build and establish a big, evolvable business long term, that's the approach that Hardy should probably take, right? So I'll show you kind of 2 ways to do this. And back to what I was. Not 2 ways, sorry, 2 ends with all the possibilities in between. And I'm not saying that this is right and this is wrong. Like, depends on what you build. You can actually throw everything in one class and it can be the perfect solution for you. Or you may actually have to put some serious thinking in how you want to decompose your application so that it can evolve and meet changing requirements. And so this brings me back to trying to fit a description of what we do. This is what we do, actually. If you look at the Liferay internally, it's a services platform, and everything we provide is provided in forms of services. And we have services like CMS, document management, user management, blogs, whatever. And they're all services, right? So you can just say, I need this service, contact this service, whatever. It's all managed in one platform. But when I explain this to people who are doing Spring Boot, they're like, why in the world you need that? Right? So because we can't fit in a buzzword, it's kind of hard to explain. And this is where my major problem is with the famous thing that there are two things hard in computer science, caching validation, naming things, and off by one error. And I particularly have the issue with the naming things, because this is what we seem to be having these days. It's like someone tells you, well, some people got together and figured out a solution for a problem, and they coined a name for it. They call it clean architecture, DDD, reactive, whatever. And what they had in mind is fine, and then you have a bunch of people all over the world that's going to come and say, no, that's not how you do microservices. That unless you use Spring Boot, it's not microservices, right? That's not clean architecture. Clean architecture looks this way, right? And then you have all these people around the world arguing about what is clean architecture, what is microservices, what is agile, what is whatever, right? Because we have this need to make everything fit into a buzzword, right? And I really suggest we shouldn't be doing that. We just need to get the job done. That's what we need to do. And it doesn't matter which buzzword it fits in. So back to cleaning and tidying children's rooms. If you think about it, why would you tell your kids to clean their rooms? Is it that important for you to have the rooms clean? No. It's because when you want to establish in your kids the habit of building things or keeping order of things, right? And when they have this habit of like keeping an order of things, then they'll start looking around in the future and say, okay, this is a mess, let's fix this. And this is what you want, to grow your kids, that they have this habit in them. And it's no different with the Java applications, or as a matter of fact, any other applications. It doesn't matter how clean your code is today, it eventually is going to get dirty and messy because requirements change, because the world changes. And so it's not about telling you this framework is going to solve all your problems. It's about getting the habit of looking into the code and say, okay, this code is not properly decomposed. It has these limitations. It may work for this case, but it prevents me from growing. Right? So the purpose in both cases is to keep your environment safe and livable place. Thank you. Do we have time for questions?
3 minutes.
3 minutes, okay. Any questions? Here you go.
Thank you for the presentation. I have the question, what's the difference between your framework and, for example, dependency injection implementation in Spring? And, for example, is there any benefits in your framework comparing to the Spring framework?
Okay, let me start by saying I'm by far not a Spring expert. I've used Spring a lot, but don't consider myself to know what's the most recent thing in Spring. The fundamental difference between modular systems in general and Spring is that Spring expects by design, and if that's changed in the recent years, probably someone can correct me, but by design, Spring expects everything to be available on the class path. And then Spring takes control over the thing. So the moment you are outside of the Spring context, you don't get that anymore. So if you probably can get very similar thing if you dedicate yourself fully to Spring. You will say, my application is like governed by Spring, and nothing else is allowed to exist in there unless governed by Spring. You may be reaching that kind of isolation, but it's I think it's going to be more code and more complex for developer to go and figure out. Whereas in these both cases, whether that's JPMS or OSGI, you are limited by the Java platform or the class loader, and basically say, no matter what kind of tricks you want to do, you can't, right? Even if you're in a Spring application, I can still do like get this class set accessible, blah blah blah, and like work around Spring, right? If I'm like a clever developer and I have issues with Spring, that's what I would do. That's what clever developers do. They work around things, right? With JPMS and OSGI, you simply cannot do that. No matter how hard you try, right? And that's one of the reasons why so many people hate OSGI, and one of the reasons why so many people will hate JPMS long term is because it does not allow you to do those tricks that we are used to do in the past. Anyone else? Here.
Thank you. I have a question regarding OSGI and how well can it be embedded in existing applications? Does it impose any restrictions on what an application is?
What an application is? No, it's very well embedded in way too many applications out there. It does enforces you though to use clean boundaries between your modules, right? So if you run with an OSGI container, like that's the thing that run, and everything runs inside the OSGI container, well then it's like applies to everything. If you run it like we do, we run just a web application that has an embedded OSGI container in it, well then it only applies to the modules, the extensions of the platform, right? Outside, you're still free to do whatever you want. So yeah, you can use it like any way you wish. It's absolutely easy to embed it. It's like 3 lines of code. But the moment you start working with it, you have to understand what the rules are and follow them. And if you try to fight it, you're gonna hate it. I can tell you that from experience. Every single person I know that has tried to fight OSGI, and every single person that will try to fight JPMS will simply hate it.
I see. Thank you. So it's not necessarily controls the execution of your application. OSGI. It's not a framework. It can be embedded in
it's a runtime. That's the difference between OSGI and JPMS is that JPMS is basically on the Java platform level, right? And you have it on or off. That's no, like it's either there or it's not there, right? And if it's there, it applies to pretty much everything. Like with OSGI is based on class loaders, so you can have in a standard Java 8 application that is totally non-modular. And then you can say, but for all my like extensions, I want them to comply to those rules, right? And then you embed OSGI in it, and that's exactly what Liferay does. So we want to have the flexibility to do stuff any way we want, but when it comes to people extending our platform, we don't want them to mess up with everything. We just tell them, that's for you, that's extensible, and that is don't touch, all right?
I see. Thank you.
You're welcome. I think we are at time, or aren't we? Or do we have any more questions? Okay, no more questions. So thank you guys. I'm going to be around for a while today and tomorrow. So if you want to talk to me about any of those stuff or any other modularity stuff, feel free to find me. I'm happy to talk to you about it. Thank you very much.